Hi, it's Mrs. Pope, and today we're going to talk about solving systems of inequalities. We're going to do this graphically today, and our goal is to find the ordered pairs. Notice I said pairs because we're going to have a bunch of different solutions instead of just one, but whatever x and y's that satisfy all inequalities in the system. Just a reminder, a system is when you have more than one inequality. We did systems of equations, which were more than one equation, so now a systems of inequalities is more than one inequality. Okay, let's see why we would do something like this. Think about space shuttle. You know I'm not an artist, we've already figured this out. But here's my space shuttle. In order for the space shuttle to take off, we have to have certain conditions that must be met. The temperature has to be more than 35 degrees, but it also must be less than 100 degrees. And the wind speed has to be less than 30 knots. So these are three different conditions that need to be met in order for the space shuttle to take off safely. So we have three different inequalities. T is greater than 35, T is less than 100, and then W, the wind speed, has to be less than, is that right? Yeah, less than 30 knots. So these three together would be a system. We don't want just one to happen or just the other. All three of them need to be met. So because there's more than one condition put together, that means it's a system. So let's look at another example of when we could use this maybe in the real world. Let's say that the Spartans Athletic Club wants to print Beat Purcell shirts for the home football game. Well, let's say we want to print 120 shirts, and they're $22 for sweatshirts, $15 for t-shirts, and we want to get $2,000. That's our fundraising goal. So we want to fundraise by selling these t-shirts. Let's see what we can do to make this happen. Alright, so let's say equation 1, S is going to be our sweatshirts, T is going to be our t-shirts. So the first thing, if we want to look at our money, our first thing is how much money are we going to make? Well, we knew from before that it's $22 for each sweatshirt. So I'll charge $22 per sweatshirt is what I'll make, plus $15 for each t-shirt. And since this is a fundraiser, we want to make at least $2,000. So this money that you bring in must be greater than or equal to $2,000. Notice I said greater than or equal to. We wouldn't be mad if we made more than $2,000. So the equation 2, this is actually going to be our quantity. So how many shirts? I said that we only wanted 120. So S plus T, sweatshirts plus t-shirts, must be less than or equal to 120. So these are our two inequalities, and it's a systems of inequalities. So what I've done is I've graphed them here. So the green one here, this is our money. This is the money. This is 22S plus 15T. If you need a reminder on how to graph them, you can go back to graphing equations in standard form. But this is it graphed. I used the X and Y intercepts. So here's the green equation, the money equation. And the red one is the quantity, how many shirts. So the green and the red intersect at one point. Well, that one point, if we were solving a systems of equations, that one point would tell us exactly how we could make $2,000. But we don't want exactly $2,000. We'd be happy if we made more. So let's graph it as an inequality. Just keep in mind, that's exactly $2,000. I just wanted to let you know what that one was. But we want to graph this line, where this line is greater than or equal to. So we want to shade everything above. We're shading everything above the green line. So that shows me greater than that equation. And now I want to shade everything below this one, because it needs to be less than or equal to 120 shirts. This is our red line. I want to shade everything below. This is everything below the red line. And you can already hopefully see where these two overlap or intersect. So there's only one place, it's right here. All of this is where those two intersect, where I had black and blue. So any of the ordered pairs that fall within here would satisfy this systems of equations. So something greater than 91, and between 91 and 120, that would be for the number of sweatshirts. And then here, again, this is a rough estimate. If you had it all graphed on your calculator, you could see the exact points. But any ordered pair in here would satisfy this. If you tried it, 91 and say 15. If you tried that, you would see that it satisfies both inequalities. So what I'm looking for graphically, though, is I want to see this overlap, where the two systems overlap. Okay, let's look at another one. We want to find the intersection. So y is greater than 2x minus 4, and y is less than or equal to negative 1/2 x plus 3. Let's graph both of them and look at the intersection. So the first one is a dashed line because we do not have or equal to. So I'm going to graph 2x minus 4. Well, of course, I go negative 1, 2, 3, 4, graph the y-intercept, and then I'm going to go up 2 over 1, up 2 over 1, up 2 over 1, dashed line, so it's going to look something like this. And then if I graph the other one, y is less than or equal to negative 1/2 x plus 3, go up 3, and we want to go down 1 over 2, down 1 over 2, down 1 over 2. This is a solid line. So now that we have the lines, let's shade them. The first one, greater than the black line. So I want to shade above the black line because it's greater than. So all of this is going to be shaded. But I also want to shade below the blue line. So all of this is going to be shaded. Your answer again is where they overlap, where they intersect. So sometimes it helps to use colored pencils or something to show me where the intersection would be. The solution is any ordered pair in the overlapping section. So you could pick any x and it's matching y. It doesn't matter. It's going to solve this. It's going to satisfy the systems of inequalities. One more quick example. All right, let's solve these two. Graph the first one, x plus 5. Remember, my slope is 1, so 1, 2, 3, 4, 5. And then I'm going to go up 1 over 1, up 1 over 1. Solid line. Then we have another slope of 1, but I'm going to go down 4, down 1, 2, 3, 4, up 1 over 1, up 1 over 1. And then I'm going to, this is a dashed line. Now, if we shade above the first one, so we want to shade up here, and this says shade below the second line, down here, what do you notice? There's no solution, because these two do not ever overlap. This would be no solution. So there's nothing that would satisfy this systems of equation. Thanks for watching, and remember, you are responsible for your own learning.